Yay, okay. Let me get this up here. So we're going to start, I think it's on page 101 today, and we're going to start now. These next 4 sections are heading into factoring. Factoring is super important for 1325. It's sort of important for 1324. It's not as important, but for 1325, it's extremely important. So I want you to be aware that when I get to 4.1, she factors using a method called grouping. I'm not a fan of grouping. I know 5 ways to factor. I mean, you factor using boxes, in your head, grouping. There's what they call the ice cream scoop or bottoms up. And the method I particularly like is called Barry's method or backwards Australian method. All right, now, you may not have ever seen my method before, but I like my method and I think it's easier than the others. So as a high school teacher, I had the most luck with that. So when we get to factoring, I'm going to be deviating from her notes a little bit because she goes into grouping, and I think grouping of the 5 ways to factor is one of the more difficult ways to factor. So I'm gonna show you my Australian backwards method or Barry's method. So we're gonna talk about that. But for today, we're just gonna talk about multiplying polynomials and then lines. All right, let me get my notes up.
We're doing 1.2 right now, right?
We're doing 1.2 today. Okay, so we're gonna do 1.2 today, 2.2 in class on Thursday. I have videos on 2.1 and 4.1. I put them up a little while ago. Okay, so they're good to go. Let me get one note. That's what I want. All right, and that doesn't look like where I want to be. I want to get to page 101 first, I think. Sorry, I got to get back up to where it was. There we are. All right, yeah, it's on page 101 is where we're going to start. So for my class, we're just going to talk about multiplying polynomials. The only reason you really need to do this is because then we're going to go backwards and learn how to factor. So multiplying polynomials, there's 2 ways to do it. This is one way, it's called the distribution method. What you do is you take basically every term by every term and you add them up. So like when I have 3g minus 3 in parentheses times the other guy, what you want to do is you're going to take the first term and you're going to multiply it by all of the terms in the second guy. So she's got it here. I'll just do it the way she did it. It's 3g times 2g squared. So she did this one. Then she did 3g times 4g. Then 3g times negative 4. Okay, so she multiplied the first term by all the terms. And then she takes the second term, negative 3, and she multiplies it first by negative 2g squared, then negative 3 times 4g, then negative 3 times negative 4. So we multiply every term by every term. And then we collect like terms. So she multiplied this through. 3 times 2 is 6. G times g squared is g cubed. We have plus 12g minus 12g squared because there's 2 g's, minus 12g. Then we have a minus 6g squared minus 12g and plus 12. All right, so she's multiplied them all together, and then we collect like terms. I'm personally a fan of lining these things up. Minus. All right, so we add up terms that have the same base and exponent. So I've got a 6g cubed. 12 minus 6 gives us 6g squared. Negative 12 and negative 12 is negative 24g, and then plus 12, right? And that would be my final answer, okay? So that's how I multiply. Some people in high school like to use the box. I don't care if you use the box. I think the box is slower for factoring, but if you want to do it for multiplication, I'm fine with it. It's just, I'm going to show it to you just in case you go, oh, yeah, I remember that. I really liked it, okay? So with the box, what you do, it's another method to multiply, is you make a box. There's 2 terms here and 3 terms here. So I make a 2 by 3 box, just by the number of terms. And I put the terms on the outside of the box. So 3g minus 3. And then on the top, I put 2g squared plus 4g minus 4. All right. And then I multiply every row by every column. All right. So like I do 2g squared times 3g is 6g cubed. 2g squared times negative 3 is negative 6g squared. 3g times 4g is 12g squared. 4g, that's going to be negative 12g. 3g times negative 4 is negative 12g. And negative times negative is positive 12. All right. So this gives me all the same terms. And then I just add up like terms. So I have a 6g cubed. And then I have, these guys have the same power. So 12 minus 6 would be 6g squared. And then I have a negative 12g and a negative 12g. So that would be minus 24g, right, plus 12. So if you want, you can do the box. I don't care how you do it as long as you can multiply. All right. Is this all right? All right. All right, so when you multiply, so we're just going to do some practice. Like when there's one term, you just straight up distribute, right? So you do 2x times x is 2x squared, and carry down the plus. 2x and 3 would be 6x, right? So I just multiply through. Right. Is that all right? Okay, so let's try another one. You guys tell me, what's 2x squared times x cubed?
Is that 2x to the 5th power?
Good, yes, all right. You last time I was banking on somebody not getting this right, but you're right. You add the exponents, right? Because you're multiplying. Remember the rules, when you multiply, you add the exponents. So, you know, we're just
When
using,
do you multiply the exponents?
huh?
When do you multiply the exponents?
You add the exponent. Yeah, you're multiplying the numbers, so you're adding the exponents, right?
Well, yeah, but there's a point in time when you're supposed to multiply the exponents, right?
Yeah, you multiply it when you have something like this, x to the a raised to the b, right? That's when you multiply them, right? But we don't have that in this situation, okay? I'll make sure you guys are aware, you just add the exponents. All right, so then I have 2x squared times plus 3x times 3x, so that would be 6, and we have 3 x's, so 6x cubed. Is that all right? And that's all I got to do. All right. So this next one, we're going to have to distribute or do the box. You guys have a preference? You want to do the box or distribute?
Box.
Box, all right. So it's going to be a 2 by 3 box. Negative 3x minus 4, x squared plus x minus 3, right? So multiply the first guys. So negative 3x cubed. X squared times negative 4 is negative 4x squared. X times negative 3x, negative 3x squared. X times negative 4 is negative 4x. Negative 3 times negative 3x is 9x. If I multiply the last ones, I get 12. Okay? Then I'm going to combine like terms. So negative 3x cubed. And the x squareds are here. So negative 3 and negative 4 is negative 7. And do the x's. 9 minus 4 would be plus 5x. Right? And then we're back to plus 12. Okay? Is that all right? Okay, this next one, I'll do the distributing method. So we're going to do the first guy times this guy. So x times x is squared. And then the first guy times the second guy. So that would be minus xy. Now we're going to do the second term. So y times x, I'm going to call that xy. It's the same thing. And y times negative y is negative y squared. okay? So these guys cancel because they're exactly the same. One's positive, one's negative. So this ends up being x squared minus y squared. When we get to factoring, this is what we call a difference of squares. We're going to go the other way when we factor. But when you have the same thing plus and the same thing minus, the outside, the terms are going to cancel and you're always going to get this difference of squares. All right, which is going to become important when we factor. All right, we good? All right, so they have a special term for it when it's a binomial times a binomial. A binomial meaning it has two terms times two terms. They use something called FOIL. You guys remember FOIL from high school? FOIL stands for first, outside, inside, last, all right? So FOIL stands for multiply the firsts, inside, outside, last, insides, outsides, lasts, okay? So when you have a binomial times a binomial, so if I multiply the first, this guy times this guy, it's the first one in each list. So it's 10x, 5x times 2x is 10x squared. Then I'm going to multiply the insides. The insides are the two guys in the middle. So I do -3. Oh, outside, sorry. Leave the outsides. Just because this so stay consistent. All right, outsides. The guys on the outside. So it's 5x times 7 is 35x. Then I'm going to do the insides. The two on the inside, -3 times 2x is -6x. And then I'm going to do the last. So -3 times 7, -21. All right. So once I've multiplied everything by using FOIL, I just combine the two guys in the middle. The two terms in the middle have the same variable. So we're going to combine them. 35 minus 6, that turns into a 29x. Now I'm multiplying. Okay. So this process is called FOIL. First outsides, inside last. All right. So we're going to do a few of them. So we're going to do FOIL. So first thing I'm going to do, I'm going to multiply the first. So x times x is x squared. Outsides, 5 times x, 5x. Insides, -2 times x is -2x. And last, -2 times 5 is -10. Right? So now I've multiplied everything by everything, combined the outsides and insides. 5x minus 2x is 3x. And I'll multiply. Okay, is this all right? Yeah? Okay, so let's do another one. All right, so first would be, you guys tell me.
6x squared.
6x squared, it's outsides. Outsides. Okay, negative 21x, right? Insides. 8x, and lasts -28, right? Then I combine the two middle terms. Let's see, -21 and 8. That's -13. Is that right? All right, and I'm done. Okay. So this is always first, outside, inside, last. All right. This is kind of preview for factoring, because for factoring, we're going to go from here to here. We're going to go backwards. All right. All right, I'll tell you what, I want you guys to do C by yourselves. And when somebody has the answer, tell me what the answer is. Anybody have it yet? All right, keep working. Anybody have it?
X squared minus 40 and x plus 3.
Yep, you got it. All right, do I need to go over that one? You guys good? We good? All right, that's what you should have got. So we'll do one more first. 3x times 3x is 9x squared, not 6. Outsides, it's minus 21x. Insides, plus 21x. And last, 7 times negative 7, it's negative 49. So those x's go away because they cancel. And this is your difference of perfect squares again. Notice that always happens. You have the same thing plus something and something minus something, right? They're always the same. All right, because we're going to go that way, I think, tomorrow. All right, we good with that? Okay, so that's my stuff for today. Is just multiplying polynomials, pretty easy. We're going to go up and we're going to look at lines, which are sort of 1324, but sort of not because, I mean, lines are lines. I mean, so, but you're going to have to work with lines in 1324 when you get to profit, revenue, cost, and when you get to supply and demand. So we're going to go up and work with lines. All right, so we're going to go up in our packet. I don't know what page it is. Let me see if I can remember. I'm looking for 1.2. I did matrices the other day. Here it is. All right. So that's in our packet. That's on page 29. Is where we're gonna start. Okay, we're gonna go on page 29. So we're just gonna do some background information on lines. This is really something that is more 324 than 1324 because in 1324 you're applying them. But there's some things you know about lines. If you know a couple points, you're in good shape. So let's talk about lines. A line. If you remember this, one way to write it is y equals mx plus b, where m is called the slope. It's a measure of the rate of change of line. And b is called the y-intercept. So when I have a graph, a line looks like that. B is where it crosses the y-axis. So this point right there is B. It's where it crosses the y-axis. The slope is a measure of the steepness of the line. A few things about slope. This particular line has a positive slope. It's rising from left to right. This particular line has a negative slope. It's falling. Horizontal lines have zero slope. They don't have any slope to them at all, no steepness. And vertical lines, strong vertical line. Their slope is infinite or undefined. It's really infinite. It's infinitely steep, okay? So these are the type of lines you run into. You want to know what's positive, what's negative. So the x is what they call the input. It's the independent variable. It's the value on the x-axis. It causes y to change. Y is the y-axis. It's the output. It's the dependent, right? Because y depends on x. Slope, some terms for slope. It's the change in y over the change in x. If I know 2 points on a line, I can determine the slope. It's the change in y, so it's y2 minus y1. over x2 minus x1. So if I know 2 points, it's enough for me to determine the slope. All right, another word for slope is rate of change. When you hear the rate of change, how fast is this changing? It's the slope, all right? In a graph, looking at a graph, we look at slope and rise over run. Or in other words, we call it the change in y over the change in x. All right, and delta means change. Okay, that's the Greek letter delta. All right, so the slope is the change in y over the change in x. It's how fast y is changing as x is changing. Oh, I should talk about some more of these just so you know. So there's three equations of the line. Standard form is not terribly interesting because it doesn't give you a lot of information about the line, but that's still a line. The way that I can recognize a line, they all have an x and a y in it. They don't have an x squared, they don't have a y squared, anything, if it has any powers of x or y, it's not a line. All right, so this one is what we call point slope form. This is useful when you have a point and you know the slope. So m is the slope, and point x1, y1 can be any point on the line. Okay, so that's useful when you have to do it by hand and you know the slope and you have a point. Okay. All right, good. Still, some people still write, so I'm gonna come and chill for a minute. All right, so some questions they might ask you. They're asking you, is the point 3, 2 a solution to this? Well, if they're asking you that, this is x and this is y, and if it's a solution, I should be able to plug them in and that equation should work out. So if I plug that in, I do 3x is 3 minus 5 and y is 2. The question is, does that equal 1? That's what I have to ask myself. If it equals 1, it's a solution. If it doesn't equal 1, it's not. So 3 times 3, that's 9, minus 10. I get negative 1. That does not equal 1. So it's because it doesn't work out, I don't get the right answer. The answer is no, it's not on the line. Okay? If I got something like 1 equals 1, yeah, then it'd be on the line. It'd be a solution. All right, another way they can ask this is they say, is this on the graph of the line? It's the same thing as to asking you, is that a solution to that? So this is x and this is y, and we're going to just plug them into the equation here. So if y equals 2x minus 8, let's see, y is 4, and x is negative 2, right? And I would get 4 equals negative 4 minus 8. So the question is that true? Well, no, right? So no. All right. So if I got the same thing on both sides, I would know, okay, that's a point on the line. All right. Now, when you're given a graph, you know, I could find 2 points and do y2 minus y1 over x2 minus x1, but don't really need to do that. Remember what a slope is. Slope is rise over run. So what you just need 2 nice points on a graph to find the slope. A nice point is at these hash marks, is where the grids intersect. So they've marked 2 nice points for us here, here and here. So to get the slope, all I have to do is count the rise and the run. So I draw myself a little triangle. You're above or below it, it doesn't matter. All right, so then I count. The rise is 1, 2, 3. I went up 3. And the run is 5, right? So I went 5 that way. All right. So pretty much if I know that slope is rise over run, okay, the rise was, I went up 3, and the run was, we went over 5. And I know that's positive because that line is going up. All right, so from left to right, the line goes up, so there's a slope. All right. So we can do the same thing. let's go up and over. So from point to point, I'm going up, count spaces, 1, 2, 3, 4. I went up 4 spaces and over 6, over 6 spaces, right? So my rise is 4 and my run is 6. So we get 4 over 6, which I can reduce that and make it 2/3, right? I want to reduce it if I can. All right, so just to see if you guys are paying attention for this graph, what's the y-intercept? What's the value of b? What is it?
2.
2? Are you talking about the first graph or the second graph? It's 4, right? This is your b? Right, for this graph, no, it's not 2. How did we get 2?
I thought you were on the third graph.
Oh, okay. I was trying to figure that out. I was trying to figure out how we got 2. Okay, we was on the third one. For the third one, that's right? Just kind of, okay. So if I get the slope, again, they didn't give me 2 points, so I have to make my own. Any 2 will work as long as they're crossing. Here's a nice point right here. And here's a nice point. It doesn't matter what 2 you use, okay? So I'm going to do rise over run. So I go down this many and over this many. Excuse me. Down 1, 2, 3, 4. So I went down 4 and I went over 2. All right, the slope is negative because I went down. So the slope is rise over run. So it's negative 4 over 2. I can reduce that and make that negative 2, right? Okay, one more. Again, it's up to you to pick some nice points. Let's see, where's a nice point? Here's a nice point. And we'll do this one. There's a nice point. Okay, so I'm going to draw myself a triangle. Rise, run. So I'm going to go down 1 and over 1, 2, 3. So my slope. Rise over run, negative 1 over 3. Is that all right? Now she's doing something here that you might think is a little strange, and I get what she's doing. I'm going to try and explain this in a little more detail. She says, if you understand the concept of slope to be the movement from one point to another, using the relationship of rise over run, you can build a second point. The reason that you want to do that, if you have 2 points, you can plug them into the calculator and get the equation of line. So all you need are 2 points, all right? So we're going to talk about how to get the second point. So what she has here, so it says, we know we have a word pair 3, 2, and the slope is 3/5, right? So I want to build a second point. So what she says is you're going to plot the point 3, 2, okay? And then we're going to count, let's see, our slope is rise over run. So from our point, we're going to go up 3 spaces and then over 5. And I can read where I landed, all right? So I went up 3 and over 5. And if I read the graph, I landed at 8, 5. So that's the second point, all right? Now, why do I want the second point? Yeah, this is where I want to do this. All right. If you know 2 points, you can plug it in the calculator and you can get the slope. You can get the equation of line. Let me kind of talk to you first before how to do this by hand. Normally, without a calculator, you could use point slope form, all right? M is the slope and x1, y1 would be your point. Which you have here. So what I could do, here's my point. So this is your x1, y1, and that's your m. So I do y minus 2, m is 3/5, times x minus 3. So that would be the equation of that line. See, I just plug the point in, I plug the slope in. This is how to do it by hand. Now, if I wanted to solve for y, I'd have to do a little bit of math. So I'm going to go ahead and do that. Distribute the 3/5. Plug it into a calculator, you're going to get 9/5 here. If I add 2, I get y equals 3/5 x. So 2 is what, 10/5 minus 9/5. You're gonna get 1/5 if you plug it into a calculator. So this would be the equation of the line. Now this is how to do it by hand. You don't have to do it by hand, you have a calculator. So if you have that second point, 3,2, because I know it passes through 3,2 and 8,5, I can plug this in the calculator and I can find the equation of the line. So that's what we're gonna do. And we'll verify that that works. All right, so I'm gonna plug it in my calculator. So the way that you do that is you're gonna hit stat button right here and then edit. So it's already at edit, so just stat enter. And I'm gonna enter those points. Now I have stuff in there. I'm gonna clear it out by hitting clear. See that clears out the lists? I just go up to the top and hit clear. Do not hit delete, all right? If you hit delete, the list will go away. I mean, I'll just show you what happens. If I go up here and I hit delete, see my L1 is now gone, right? And you're like, how do I get it back? Get it back by resetting the calculator. So just to show you how you do that, second, memory. I want to reset 7. I think I want to reset all and all memory. I'm going to hit yes, please reset. All right, so now when I go back to stat and edit, the list is back. All right, so if you're missing a list, that's how you get it back, is reset the calculator memory. All right, so we're going to enter the points. So you just type L1 is the X and L2 is the Y. So it's 3, 2. And the other one was 8, 5. 8, 5. All right, now I have them in L1 and L2. I have to quit out of that. So I hit second and quit right here above mode. Okay, now those are stored in memory. So what I do is now I want to get the equation of line. So you go to stat, that's where all your statistics is. You go over to calculate, CALC, and I want linreg, number 4, stands for linear regression. It's the equation of line. So I want number 4. See how it says L1, L2, that's where your X's and Y's are. And we type calculate, and there it is. I get the equation of the line, 0.6x plus 0.2. So I'm going to verify. I wonder if I could do that. I'm going to try something, may not work. I can't probably just convert them to fractions. No, okay. But I can do it this way. I can do 0.6 and write it as a fraction. I get 3/5 and 0.2 and write it as a fraction. I get 1/5. So I get 3/5 x plus 1/5, which is what I got by hand, all right? So just to show you, it does the same thing, all right? So feel free to plug points into the calculator. You only need 2, okay? All right, so let's make sure we can get the other points. All right, we good with that? Yeah, okay. So it wants me to find another point. All right, so move from the given point using a slope of 2/3. So this is telling me to go up 2 and over 3, right? So rise over run is 2 over 3. So from that point, you're going to go up 2 over 3. That puts me right there. So I can read that point. That point is 6, 6, right? Okay, see, I'm using the slope to find another point. Now, here, if I try to go, the slope is -4 over 5. So if I go down 4 and over 5, you see I run out of graph? But I can go backwards, right? I could write this as 4 over -5. So I go up 5 and 4 to that way. What is that left? All right, so rather than, because I ran out of room, oops, I'm going to go the other way. So I'm going to go up 4 and 5 to the right, to the left. And I end up here, all right? So now I'm at the point 0.6. And you can verify that by going the other way. If I go down 4 and over 5, see, I'm at that point, right? So I know it works, all right? So the point is, if I got one point, I can always get another point, and then my calculator's, like in business. All right, so do we really need to graph it every time? The answer is no, all right? if you understand that slope is rise over run, you don't even need to graph it. So if here's a point, and if I know this is the slope, I'm going to write this as -4/15. That's rise over run, so which is basically the change in y over the change in x. So this tells me that y is going to go down 4 when x goes up 15. So from this point, this is x and y. So I can do 350, 20. To get another point, I'm going to make y go down 4 and x go up 15. So I just add 15 to x and subtract 4 from y. So I end up with 365 and 16. So that would be another point on that line. See, I can always get another point if I know the slope. Okay, so let's try this next one. I have the point 30, 6,400. So 2 over 35, remember that's the change in y over the change in x. So y is going to go up 2 when x goes up 35. I add that, you get 65, 6,402. And that would be another point on that line. All right, now, last one, and we're going to show you some calculator. All right, so 30, 6,400. Now the slope is 40. Now it's change in y over change in x. So here it's not a fraction. So the way that I write it as a fraction, I just put it over 1, right? Because 40 is the same as 40 divided by 1, all right? So the change in y is 40, and the change in x is 1. So I'm just going to add 1 to x, and I'm going to add 40 to y. So I end up with 31 and 6440. So that would be another point on that line. So what we're going to do, just to use the calculator again so you can see the calculator, I'm going to plug the points into stat. We're going to find the equation line. I'm going to show you one more trick with the calculator. All right. So let me move this over here. All right. So what we're going to do is I'm going to press stat. Edit. I'm going to go up and clear this out. Don't hit delete. Alt2, hit clear. All right. So let me put those points in there. We had 30 and 6,400. Oh, enter. I have to hit enter after these. All right, 6,400. And then I have 31 and 6,440. All right, so I've got those in there. Once I have them in there, I quit. So I hit second quit, second mode. All right, I'm going to go to stat. And I'm going to go to calculate. And number 4, lin reg. Now, a couple things I want to tell you, or one more thing I want to tell you about. If you want to store the equation so you can graph it, there's this thing called store equation. You can actually put it into a grapher thing. The way that you do that is I go down here and I say, all right, I'm going to pick variables, VARS, go over to Y variables and functions, so press enter. And there's your list of all your graphers. So I want to store it in Y1. And then I'm going to go hit calculate. And it gives me the equation. It's 40x plus 5,200. The slope's 40 like I expect. But if you go to y equal, because I stored it, it's there in my grapher now. All right, so that's a nice way to store the equation of lines. All right, when you find them. All right, so, and that's that. You know, I could graph it. I won't see much. I'd have to change my window. There's line. Okay. Anyway, so the whole point of this is if you know one point is slope, you get another point, and then you're home free with your calculator. You can plug it in the calculator to find the equation of the lines. Okay. All right. Now, that's that. All right. So, like I said, I'm done. The videos for 2-1 and 4-1 are up already. I think I just got your grades in, or most of them. And like, don't forget about the homework and the quizzes, right? Because, you know, they can be done late, but they should be done. I'm seeing some people locking up some zeros here. We did 1-2, we'll do 2-2 on Thursday. The deal with factoring is, like I said, I'm gonna deviate from my notes a little bit because I do it a little differently than she does. Okay, so just be prepared for that. The video on 4.1, I'm using my method. So, you know, I really like my method, but just be aware of that, okay? You have a quiz this week. Like I said, next Friday, you'll have your first test. That'll be through HonorLock. It's a multiple choice 20-question test, 21 questions, something like that. And you got like, I think I gave you 90 minutes, which you don't need 90 minutes, but I gave you that, you know, and then there's a review, which I'll put up there on Thursday. We'll talk more about your test on Thursday, okay? So I'm pretty well done. All right, any questions?
I have a question.
Yeah. Go ahead, Bryce.
Yes, do we have to have a whiteboard?
No, okay. I don't like the whiteboard. What I do is I let you have scratch paper and a graphing calculator on the test. You can have blank scratch paper.
Okay. That works.
Okay.
And
I'm not a fan. If you want to use the whiteboard, you can. I'm just not a fan of it.
Okay.
Right?
I have a question.
Yeah.
Do we have to show you our work for every single problem on the exam up to the camera?
No, it's multiple choice. You can just, at the end, just show your paper that you were writing.
Awesome, thank you.
I'm not that worried about this.
Our other professor is going a little bit overboard. She's expecting us to show her our workspace, show her that we're writing the problems out with a whiteboard for every question. She's expecting.
Sorry, I'm not doing that. No, I'll explain.
Okay.
What I expect. It's nothing like
Yeah.
that.
She's also expecting us to show her under our desk, and like we have nothing else in the room, no background noise.
You have to do that. You have to do that for
Okay.
our, you have to show the, whatever, the camera round. You have to show that, right? And
No, yes, ma'am, I understand that, but it's my other professor, he doesn't make us, like, of course, he makes us show us the room and stuff.
yeah.
But like, I feel like this is a little extreme, maybe.
Yeah, I mean, what I do, I'll tell you guys on Thursday is, you know, you have your graphing calculator with you. That's allowed, right? You're allowed to have blank scratch paper. So you show your paper at the beginning, hi, you know, it's blank. And then you show your paper at the end, hi, I wrote on it. Okay. I mean, I don't care because it's a multiple choice test. Okay. That's all I want. Okay.
Yeah, it just seems like she's going a little bit overboard with the procedure.
If somebody wanted to cheat, they could cheat. And I'm not going to, I mean, you guys hopefully are honest enough not to, but you know.
Yes, ma'am, of course. But yeah, I understand it, but
To a limited, you know, I mean, you have to realize when you take a class online, if you wanted to find a way to cheat, you probably could. But the question is, you know, what value is it? I don't know. All right, I'll see you guys. All right.
I had a question.
All right, have a good couple days.
I had a question, Miss Miller. I guess not. All right, bye-bye.
I'm just hanging out by see if anybody has any questions.
I do.
Yeah,
I've got a question.
yeah,
Can you hear me?
I can hear you.
Oh, okay. I don't know if somebody already brought it up or not, but I wasn't able to view the 8.5 lecture.
Yeah, it's my fault. The link was bad. The link is now good.
Oh, okay. All right.
It's up there. It was for some reason part of it got cut off, but it's
Along with that, I emailed you as well, but I couldn't access 2.4, the video for that either, along with 8.5. I know the 8.5 link is good now, but I wasn't sure if 2.4 is working again or not.
right, because it should be. Campus, you're KL. So let's see. We got a content. We're in exam. That's exam 2. Hello, where are we? There we go. 2.4. Yeah, if you hit the YouTube, don't do this. Oh, Oh, that's interesting. You're not gonna be able to access it through Zoom, I don't think. All right, something's wrong. Here, let me try this. Let me try copy and pasting it. All right, there it is. So just copy and paste the link and it works. All right.
Awesome. Thank you so much. Bye,
This
Professor.
first, which is pretty short today, and then we're going to talk about matrices, which is a little longer. Oh, that's me. All right, so we're in section 2. Okay, there we go. That's me. Okay. Okay. All right. And so just copy and paste it. It'll work. I don't know why it did that.
Thank you, Professor Miller.
No problem.
Are we getting another attempt on 8.5 homework now?
Sure, I'll just extend the due date.
Oh, okay, so we can take it again. I think I've already taken it twice though.
Oh, you've already taken it twice? The quiz or the homework?
The homework for 8.5.
You can do an unlimited amount of times.
Oh, okay.
So you're fine.
All right, sounds good. Thank you.
Professor Miller. Professor Miller.
Yes.
I still have not been able to get into the Pearson. I'm still confused on how to do that.
How, what?
To get into the Pearson textbook.
All right, so you can see my screen right now?
Yeah.
All right, so let me, actually, let me not record. Am I recording? I need to stop recording just a second.